Given the following data of a one-way slab, compute its design strength. Usually, yung slab analysis natin is per unit width. So 1 meter is 1,000 millimeters, that is the width of the slab. The total thickness is 125 millimeters. Spacing of the bars, it is 125 millimeters. Each of the center-to-center spacing. So later on, kailangan natin yung effective depth of the bars. That is to the centroid of the reinforcing bars, to the topmost or the extreme concrete compression fiber. Itong part na yan, beer covered plus half of the bar diameter. Kunin na lang muna natin yung effective depth based sa dimensions. So effective depth is equal to H, 125, minus cover and half of the bar diameter. The cover given is 20 millimeters. Yung bar diameter is 12 millimeters. So you have here 99 millimeters. Okay, so yung analysis natin dito is still the same as the beam analysis. So let's start in calculating the total area of steel. Paano kunin yung total area of steel? What is given here is the spacing of bars. Pwede natin makuha yung total steel area using this formula. Diba alam natin spacing per unit width, that is area of one bar over the total area of the steel in every 1,000 millimeters. So rearranging that one, AS is equal area of bar, that is area of one bar, pi over 4 times 12 squared, divided by, the cross-multiply natin to, so divided by spacing ng 125 times 1,000. Ito yung total steel area dito. So gusto natin is the design strength in kilonewton meters. Ito yung gagawin ko na. Gagamitin ko lang ng equilibrium. Di ka na dadaan doon sa RN ha. RN pag nagde-design ka. So galing sa factored moment or galing talaga sa actual load, apply to the slab. Dito, pinapakuha yung capacity ng slab. Capacity mismo. So, use tayo dito, equilibrium. Compression equal to tension. Of course, yung compression natin that is caused by concrete strength. Tension naman that is caused by the steel bars. So usually, yung ating steel bars basta slab, mag-yield talaga. So assuming steel yields, that means Fs is greater or equal to Fy. Alright, so compression of concrete that is 0.85 Fc prime, ito yung effective stress niya, area of concrete A times P, depth of compression block times the width. Tension of steel is As times Fy, assuming nag-yield siya. So, substitute natin, makukuha natin dito ang depth of compression na. 0.85 Fc prime, depth of compression block, yung B natin, assuming 1,000 millimeter width, then equal to As, Fy, kuha muna natin sa A. Okay, kung sigurista ka, gusto natin i-check kung nag-yield ba talaga, then dadaan tayo dito. A is equal to beta 1 C. Alright, where beta 1 is 0.85 for Fc prime less than 28 megapascal. Usually, hindi na kailangan dumaan pa dito. Kasi mag-yield talaga yan. Correct na agad yung assumption yan. So if A is ito, beta 1 is 0.85 that calculate for C, location of the neutral axis. After we have the C, check if the assumption is correct. This is the correct procedure. But most of the times, hindi na kailangan. Okay, so calculate for actual Fs using that formula. So 600, effective depth is 99, C is 12.522. That you have here, 4144. It is very big compared to our Fy. So correct na yung assumption natin na yield yung steel. So we can now solve for the nominal strength first. Gamitin ko na lang yung tension times moment arm. Yung tension natin is As Fy, that is our force. Moment arm is T minus A over 2. Okay, substitute for As. As Fy, may As tayo, that Fy is 275. T is 99. A is 10.644 over 2. I-divide ko na lang siya ng 1 million or 10 raised to 6 para yung result is naka-kilonewton meters. Okay, mag-ingat kayo dito. Yung tinatanong is design strength. Take note, mag-design strength, we need to multiply that one by reduction factor. And the reduction factor is 0.9 for tension control or for Fs greater than 1,000 megapascal. Okay, for that the design strength Phi Mn, P is 0.9, Mn is 23.31. So you have 20.98 kilonewton meters.